So this is the Severstal Dearborn Steel Mill. It's a factory devoted to the manufacture of steel, one of the largest in the world. It's been on the site for over 100 years. It was originally placed here by Henry Ford, the Ford Motor Company, and in 2004 it was bought out by a company called Severstal, who are a Russian company, a Russian steel mining company, and now it's in their hands. And this whole factory is devoted to the manufacture of rolled steel. 6,000 tons of molten iron every day in this facility, 24 hours a day, round the clock, every day of every year, to churn out flat rolled steel products. They just make flat steel sheets. There's a railway that they've built on site so that they can carry this huge amount of steel around. All of these, those stairs, those railings, those pipes, even if you don't know what they do, just know that they're in service of making steel. That person's on a computer for steel, that person's using that machine. It's all about making steel. There's some of the steel. So that's a roll of steel. There's a whole family, a whole little garden of steel rolls. And if you want to get one for someone's birthday, they can wrap it for you. So this is, somebody would get that and they'd be like, oh, what could it be? Oh, it's steel, the gift of steel. But you can't have steel without ore, without rocks that contain iron that are over 1 billion years old. This is stuff that's just been hanging out in the ground for 1 billion years, and you dig it up, not here, some other place that looks like hell in a different way, and you dig it up and then you bring it here by train, and then you put it in this. This is the blast furnace C. What happened to blast furnace B, you might ask? There was a horrible explosion and it was awful and they had to build another one. What happened to A? I don't even know. No one says anything about A. Anyway, they put the iron ore and the coke in here and they pump this hot air, superheated air into the bottom to make it even hotter. It reaches 4,000 degrees Fahrenheit, which is about 2,200 degrees Celsius. And they turn the iron molten. They turn it into liquid. They have molten iron. This guy's on a computer looking at a screen telling him how molten the iron is. All that green means it's pretty damn molten, which you can see here. Now this is, look, they've literally got a drill that they're drilling a hole into the clay of the furnace that releases the molten iron, and that's now the molten iron coming out of the hole they drilled into these things, which are the big bottle cars on the trains. So these are huge train carriages full of molten iron that go into this basic oxygen furnace, or BOF, or BOF. What you can see here is the truck tipping over and tipping the iron into one of these things, one of these little crucibles. I say little, it's fucking huge. And that then gets mixed with this, which is recycled material. This is scrap metal from the, it's in Flint, Michigan. There's a lot of automotive businesses, a lot of scrap metal. So about 25% of what goes in there is scrap metal and the rest is the molten iron. There it is getting mixed together. And then they put it in the BOF, the basic oxygen furnace, and they mix it. They pump a lot of oxygen in, which gets rid of the carbon, melts it all in together, and turns it into steel. Anyway, that molten steel now gets poured into another ladle, another huge, ridiculous ladle, which gets taken over to the LMF, the Ladle Metallurgy Facility. This is where shit gets really interesting if you're a customer and you're getting some steel made. So say you're getting some steel made, this is the point where you can start to add the things that are going to make the steel right for your particular purposes. So they're putting electrodes back in the steel here to heat it back up, and they're adding other things to alloy with it, like if you wanted to add some manganese at this stage, or some silicon, or some aluminium for any reason. This would be the time. And then this is another additional feature you can have for a little extra. You can get it vacuum degassed, which again takes out more of the carbon and gives you like a lower carbon, stronger steel if that's what you need. If you need your steel sheets that they're making here to be super strong, I guess. Look at the size of that thing. Look at the size of that ladle. Is that what they call it? A ladle. Look at the size of that ladle. Anyway, it's casting time. So we've got the steel, it's molten, it's got everything it needs in it, it's all steely, but it's super hot and melty, it's liquid. So we need to pour it into something now that will progressively cool it, and that's what this is. All you can see on the screen there, these are cooling elements that will cool the steel down to a point where it's not sloshing around anymore. And look, they lay it out in these flat blocks. They're like long bars of steel that they're making here. And there you can see they're cutting it, cutting it into slicing it off, and then tagging it up. So every piece gets a number, and everyone's happy. Insanely big machine there, carrying it all around. Just the sheer logistics of carrying this much steel around is insane. Anyway, we're in the hot mill now. What do you do once you've cooled it down? Yeah, heat it back up again. They're going to heat it back up again, and they're going to get it so that it's pliable. And once it's pliable, they're going to start rolling it out and making it thinner and thinner. You can see here they're descaling it. They're getting rid of the scale, which seems to be a huge part of steel manufacture. For some reason, they're plagued by scale. So here you can see they're rolling it out flatter and flatter and flatter, and they've got this huge long room that they can just make one piece of steel really flat. You can see there's loads of water around everything. Everything's about heating it up and then cooling it down again and shaping it in between and making sure everything's fine. And there's lots of computers to make sure that all the heating it up and rolling it out and flattening it down and cooling it back down again all works. And they're taking steel bars here that are like 33 feet long, and they're rolling them out into coils that are like 4,000 feet long sometimes. That's what they're doing here. They're just stretching it on out. And the more you stretch something, the longer it gets, but it's still in the same space, so it has to go faster and faster, so it's getting increasingly fast, and eventually they have to take it off the other end and coil it up. Look, we've got a robot here that's doing some testing, just making sure that it's all okay, and then it writes. The little robot arm does a little writing of a number on it. Anyway, for some of the steel, that's the end of the story. Some people just want it like that, that's all good. But there's a lot of steel that sticks around and goes into the cold rolled factory and goes in to get coated and stuff. Anyway, let's talk about cold rolling. This is going to the pickle line tandem cold mill, or the PLTCM. This is a guy, you can see a guy there doing some checking, doing some quality testing. This is serious cutting edge shit. They're getting more and more precise, and they're making higher quality cold roll steel all the time. They're just dedicated to making steel as good as possible. And a large part of that is automating these processes so that nothing goes wrong. So each of these, once you've got these rolls of steel, they're all going to have different things done to them, and they've got different chemical makeups, and keeping a track of which one is which, because they all look the same. They just look like rolls of steel. So a lot of it is like the whole system is completely automated here. You can see a machine there cutting off just exactly the right amount that's needed for a specific order, and this whole thing is done so that everything is like as little waste as possible, nothing gets lost, everything's tracked, everyone knows where everything's going. This is the cold rolling facility made by Mitsubishi Hitachi. Weird, isn't it, that these huge industrial processes are made by the same people who make vibrators? I guess so. Anyway, some kind of magic happens here, and it makes the steel even stronger and more powerful than ever before. These are two people who are doing a little strip surface inspection. They're just having a little look at the surface under tension just to see whether there's anything wrong with it. Looks like it's all good, lads. This is coming off now and being banded up by a robot, gets marked, and then they just give it a barcode like we'll never run out of those things. And then there it is. It's just going along. It's all ready to go. It's like a full cold rolled product ready to go out the door. But there is seemingly no end of things that we can do to steel to make it more ductile or more strong or whatever. For instance, here they're being put in this ominously lowering tunnel in order to create a hydrogen environment around it that will do something to it. They can anneal it, they can temper it in all kinds of different ways. I don't know, there's a bunch of ways you can spend your money, get your steel in different ways. And that's pretty much all the processing. But then what you can do is you can galvanize it. People really want a lot of different things with their steel for different specific applications. And this is one of them. So they've built this brand new, beautiful galvanizing line to galvanize it. This is only since 2011 this has been around. And this is the hot-dipped galvanizing line, or they call it the HDGL. And the HDGL is right next to the PLTCM. They just whip it on over and create a very high-powered cleaning system here, which creates a hyper-clean surface, and then they heat it up again. Look, I'm not going to lie to you. A lot of this seems to be about heating things up, cooling them back down, and then heating them back up again, and then maybe having different things in the air. There's a lot of heating up and cooling down, and a lot of the pipes around here, you can be pretty sure that they're going to be either dedicated to heating things up or cooling things down. A lot of this water around just for cooling things down. That's one sheet of steel there that's going around. This is the tallest in North America. This I don't know how much competition they have, but that's the tallest galvanizing tower in North America. Anyway, this is all starting to get a bit cosmetic. They're doing this is like a wash system. They're washing it. They're removing very fine particles of zinc from the strip, and they're making it very, very flat. Look, this person's got some calipers or something just to test how flat the steel is. Yep, looks like it's flat enough. Everyone here seems pretty chill. It looks like all the steel is exactly as flat and strong as they wanted it to be. And look what it starts from. A bunch of scrap, all different sizes, nobody knows what's going on. And then at the end, everyone knows what's going on. What's going on is that it's steel, and you can use it to build whatever you want. And all of these people know so much more about steel than you or I ever will. They just have the whole thing set up perfectly. They built this whole factory, they built those stairs so that people could move around the factory. Somebody had to design the blue casing on that. They bought this guy with the questionable tattoo behind his ear a computer. They bought this machine, presumably they had to build that from scratch, and they built it all here in Flint, back when they thought that there was going to be an endless supply of American cars going out, and then the bottom fell out of that and it had to get bought by a Russian oligarch. Hey, let's not think too hard about that. The fact of the matter is, if you have things that are made out of steel, the steel has to be made somewhere, and this is where the steel is made. And that's cool, right?